we can solve some question to practice for the lecture. In here I have prepared a simulation file, but you cannot see it. It is not needed for you. And here the same warning, only we have a difference. The remaining four question displayed on another page. Okay, the other part is the same, we can say. Okay, let's try to solve the question. Yes, it is the first question. Add the numbers that came from the port 2 and port 3. Write the required 1851 assembly program code in the solution field given in question 2. Here we have an area for the solving question 1. The box for question 1 will be left blank. This box will be left blank. Okay, we will solve the question here. That's all. Let's do this question. Origin 00 hex, sjump x, and x. We have to add the numbers that came from port 2 and port 3. So first of all, we have to get one of the number from the ports. I prefer to take port 2 to the accumulator. Why we use the accumulator for this question? Let's remember, addition command can be used only A as a destination. Okay, so we have to get a number to the, of course, accumulator. And then can we add directly A with port 3 or not? What do you think? Let's check it on the common table. Yes, here as a source we can use register, direct address, indirect address, or data. As you know, all ports are in the SFR area, and for the SFR area we can use direct addressing mode. So it means all ports can be accepted as direct address. Okay, so we can use easily this command for the ports. Okay, here we can use this command for the addition operation. We don't need to use also another register, because as you see here, addition operation, addition command can be used with A and direct address. All ports are in the SFR area, and SFR area we know uses the direct addressing mode. Yes, SFR area uses the direct addressing mode. What does it mean? In this area, all addresses can be accepted as direct address. So we can use directly add A and port 3. That's all. And what else? What will we do now? In the question, this operation will done for blah blah times or infinite times. Do we have this kind of information in the question 1? There is no any information about it should be done blah blah times or infinite times. So what should we do in the question? Yes, we have a routine infinite loop. Okay, sjump xx. sjump xx and directive. The program is finished. That's all. We get the numbers from port 2 and add this number with the port 3 and infinite loop and directive. That's all. Yes, what about the other question? If the result is higher than 158 decimal for question 1, the LED connected to the port 1.6 will be turned on. Otherwise, it will be turned off. Okay? Write the required assembly 1851 assembly program code in the solution field given in question 4. The box for question 3 will be left blank. Origin 00 hex. Maybe we can copy this part for the same. Kullanmadık. Yes, sjump x and x. In this question, we will use port 1.6 and it is activated at the starting point. So, first of all, we have to clear the related bit. Clear port 1.6. Then we can continue the program. Move a port 2 and port 3, right? Yes. Okay. Add a port 3. And if the result is greater than this number, the related LED will be turned on. How can we check this issue? What do you think? How can we check it? The result is greater than or not. How can we check it? We have an idea here. Can we use subcommand and then if we check the C value, carry flag, and then we can easily understand the it is greater than or not. Okay, where is the result now? Result is in A, and we will do subtraction operation. First of all, before using the subcommand, we should do an operation. What is this? We should do clear C. Okay. And then sub A, the number is 158. We should use also diasis sign. Yes. Let's check it, the carry flag. For the carry flag, we can use two commands. Jump carry, jump not carry. It means jump carry is if the carry value is 1, program will branch to the related label. Jump not carry, if carry is 0, the program will branch to the related label. Use here jump carry. First of all, we should think the carry means. If carry is 1, what is mean for us? Let's think about this. If carry is 1, the result is greater than 128 decimal, right? Okay. Otherwise, it is smaller. Okay. If it is greater, if it is higher, we should turn on this LED. Yes. We will use a label here, greater, for example. And if the program is continue with the next line, what does it mean for us? The condition given here is not satisfied, so the program will continue with this line. The general programming error in the exam, you used also here jump not carry and small, for example. We don't need to check again, because if this condition is not satisfied, this condition has been already satisfied, because the program will continue with this line, programming line. If your program is in this line, so it is mean carry is already 0. So we don't need to use this kind of command also. In here, we can do related operation, which is clear port 1.6. And then, what will we do now? What do you think? Because this part is important for us. What do you think? What should we do here? S-jump, blah blah. I don't know it is X or not. Okay, and then we can use the greater label here, greater, and what should we do here? Set bit port 1.6. And is there any other operation? No. Okay, in this question, do we have any information? This operation will be done a finite time, for example 10 times or 20 times. No. Do we have any information it should be done continuously? No. So we can do this operation only one time, and then program can finish with the infinite loop again. XX, S-jump, XX. So in here we should use XX, not X. Sorry about this. If your carry is 1, the result is less than this number. Okay? Not greater. Sorry. Less than this number. Otherwise, greater. So, maybe we can use here jump if not carry. On this condition, if the carry is 0, A is greater than this number, right? If it is not, the program will continue with this line, and it will continue with the same operation. Then we can continue with the next question. Do the required operation of Q1 and Q2 if the button connected to the port 1.5 is pushed and released. Okay, we will do the same operation, but we have a condition here. The related button is pushed and released, and then we will do all of this operation. Okay, and the same way, the program codes, related program codes will be written to the question 6. Yes, I will copy and paste the related program codes. In this program code, we will do a modifying, which is a button. Port 1.5 is pushed and released. So, what do you think? We should put the related program codes which line? What do you think? In here it is not Q2, sorry. It should be Q3, okay? This question. Let's remember the button. First of all, we did before an example about the button. We can easily understand the button with this example. When you push the button, as you see here, the pin is connected to the ground. What does it mean? Logic 0, okay? But if you release the button, the related port will be logic 1. So, with this knowledge, we can do the related question now. We should write some comments to the program, but which line? What do you think? First of all, we have to decide it. The button control should be in which line? Okay, in this line we should check the button, because as you see here, the remaining codes is about the question already. We should do all of this operation if we pushed and released the related button. So in here we have to check the button. We will use jump bit command, port 1.6, and if this condition is satisfied, what should we expect? If port 1.6 is 1, what should we expect with this command? If this condition is satisfied, the button is not pushed yet. So please wait. Where? Of course X. The same line. Check again, check again, check again. And then if you push the button, this condition is satisfied, not satisfied anymore, and program will continue with the next line. So here we should check the button is released or not. How? Jump if not bit, port 1.6, and wait. Where? Of course, with the same programming line. Okay. In this line, we will wait for the button is pushed or not. If it is not pushed, the program will stay on this line. And if it is pushed, the program will continue with the next line. And in this line, we'll check the button, it is released or not. If it is released, the program will continue with the next line. But if it is not released, the program will stay on this line. First of all, we can copy to the exam sheet here. Sorry. It is my number. Yes. And blah blah. I have already filled this area before the exam, and also this area, and I'll copy the answer to the related page. Yes, this is 2. Maybe I should arrange. Maybe we can copy this part also. Yes, that's all. And then 6. That's all. And then we can continue, because if you display the other page, we cannot turn back to the this page until finishing the exam. Okay, because of this I will copy first of all, and then I will go to the next page for the other question. Here you can see the position on your exam. Question 2, 4 and 6 are answered. 1, 3 and 5 is blank. It's not important for the exam. And now we are in 7, 8, 9 and 10. And we cannot go back to the other page. Okay? It is so important. Yes, repeat the control process required for question 3 using the subprogram structure. Yes, we should do control process with the subprogram. Okay, what is the question 3? Let's check it before. Yes, the answer for the question 3 in question 4. We know it. And so, first of all, we copy it to here, and the remaining part, sorry, maybe we should clear it. Yes. Now, we will do a modifying on this program, how the control process will be done in the subprogram. Where is the control process? In here, we will do addition, and we will do control operation with clear C, sub A, or not. Yes. Maybe we can include this command also in the subprogram. But it is enough for this part, for this question. Right? Is there any problem? Because we will check the numbers, it is greater or not, starting with this line. So let's try to accept this line. After this line, we will do a subprogram. Yes, a call check. Where is the check? After the call command, what should we use? What do you think? What should we use? Yes, sjump xx, because we don't want to enter in the subprogram without our control. In here we can write the subprogram label, check, and after all of it, we will check the care flag, it is greater or less than, and then clear or set bit, and in here we should use ret, as you know, because if you use any subprogram we should use ret. But also here we should do a modifying. Why? If the result is less than this number, what should we do? Clear port 1.6 and sjump XX. Where is it? Here. But we are already now in subprogram. We didn't quit the subprogram. So here we should change this as XXX, for example, and here we should use XXX. Okay. The program will tend to this label and quit the subprogram. Program will return to the sjump XX and will stay on infinite loop. Okay, we can copy this part to the answer sheet. We have also another question for the simulation. It is 10. What about the last question? Okay, here we have the last question. The division operation will be done instead of the addition in question 1. This process will be repeated for 170 times with the numbers that will came from port 2. And port 3, the number of times that division by 0 has occurred in the operations will be determined, and the result will be saved to 70 hex address. Write the required 1851 assembly program code, and in the solution field given question 10, this space will be left blank. For the first question, we will do division operation, and we will do this operation 170 times. We have to calculate, we have to define how many times we encountered division by 0. Okay, and this number will be saved to the 70 hex address. First of all, we have copy the last solution and we can do a modifying on this solution. We get the first number to the A, and we should get the second number to the where. We have to remember division command. Where is the division command? Yes, division command can be used with A and B. Okay, A and B, and the integer part will be saved to the accumulator, remaining part will be saved to the B register. We have a flag to status to show the 0 division by 0, which is overflow. Okay, if B is 0, then overflow flag will be set after the div command. So we can check the overflow flag, and then we can control for the related operation. But first of all, we have to get the second number, move B and port 3. We don't need to use clear and subcomment for this question. We will use div AB and a cool check. Let's go to the check part, and here I will erase first of all, and then we can write the related comment. We have to check overflow flag, jump bit overflow. What is mean for us? If the overflow flag is 1, it is mean that we have a division 0. Okay, then maybe we can use div 0 label. But if this condition is not satisfied, before this we have to do another operation. Why? We will do this operation 120 times, right? So we have to use a counter. And also here we don't need to use clear port 1.6. Move R6 128 decimal. Okay. And also we have to use another register to store number of the division by 0. Okay. So maybe we can use move 50 hex. No, we don't need to use move 70 hex and 00. It is the initial value. Okay. Then here, we are here now, division by 0. If we don't have division 0, S jump, blah blah, we don't know yet. But if we have division by 0, div 0, 0, we should increase 70 hex address. Maybe we should check this program code in the appendix 1. Yes, increase comments. Yes, here increase comment can be used with direct address, so we don't have any problem about it. And then we will do another operation. What? We should decrease the counter value. It is done for a value and it should be done 170 times. So we should use here the increment jump if not 0, R6, and if it is not 0, continue. Okay. In here we have a red, and is there an x1? No. Here we should use x1, a label for the thanks to the program here x1. In here we checked the division by 0 and we did an increment if we have, and we will return to the main program. Okay, main program. Where is the main program? Here we should return to this line. In here we should decrement jump if not 0. We should use this command for the counter R6 and continue. Okay, what do you think now? Where should be counter label? What do you think? Maybe we should check the program origin S jump and we set a counter for the R6 and we set 70 hex address to store the the number of the division 0, and we get the numbers from port 2 and port 3. We did division operation, a call check, we have a subprogram, and we check the overflow flag, which is used for division by 0. If we have division by 0, the program will go to the div 0. Here we increased by 1 on the 70 hex address and ret. If we don't have, program will go to the sjump x1, which is here we have ret command also. Program will turn back to the this line, and we decrease the R6 value, and if it is not 0, we should go to the continue. We should do this operation again. So we should go where? Which line? Maybe we should check the jump bit command. Yes, jump bit label. Bit is direct address. Okay, and overflow flag is on the program status word, which is used as direct address because of the SFR area. Okay, so we don't have any problem for the usage of the jump bit or flow usage. Yes, we should get the numbers from port 2 and port 3 again. So program should continue from this line. We should get the numbers from port 2 and then port 3. We'll do division operation, and then we'll go to the check subprogram. In here, we will check the related flag, and if we have division by 0, increase 70 hex, and we will go back to this line, and it will continue until the numbers will 00 hex. If it is okay, I'll copy to the exam template and save it. That's all. I'll close to related paper, and I'll finish the exam. Yes, here the status it is not replied, not replied, not replied, not replied. Okay, it is convenient for me because of the systematic of the exam. Yes, it is finished now.